Now we talk about data frames and tables, and as I anticipated earlier, data frames are among the most widely used advanced object types in the context of data science, because whenever you read data into R, it's very likely that it comes in the form of a data frame. Now, data frames are special cases of lists, and they are actually require these lists to be of to have a particular property, namely that the length of each vector making up the list is equal, such that we can basically print the list in some kind of table forms. That actually means that whatever you learn about lists is very likely to also hold true for data frames. So most list operations also work for data frames. But the nice thing about data frames is that because all the vectors making up the list are of the same length, they are usually straightforward to be represented as tables. And the print function implicitly does so when you print a data frame in R. If you want to create a data frame from scratch, you can use the function data frame. And you see here already that this looks very, very familiar to what you've learned in the context of lists. You have the name of the data frame, use the function data frame. Then first, you can specify the names of the vectors making up the data frame. So in this case, this is gender and height. Then you use the equality sign, and then on the right side of the equality sign, you type the vectors that are then actually making up the data frame. If we look at how this data frame is printed in R, we see the following. There you see the typical list appearance of a data frame. And you also see that the two vectors here show up, but in a vertical arrangement, and that here the names of the vectors correspond to the column names in the data frame. Alternatively, you could also create a data frame from a list. So you define the list previously, and then you use the function asDataFrame to transform the list into a data frame. As I said, if you read data into R, it always starts off as a data frame. And often the case, unfortunately, these data frames look very ugly. So you need to transform them in a way. So, for example, combine columns, filter for elements, etc., etc. And there will be 2 sessions on this huge topic, which is often referred to as data wrangling. Data wrangling is about how we can transform data frames from one form into the other. And this will be, as I said, it's a huge topic in data science, and it goes under the heading of data wrangling. But right now we're still only dealing with the definition and use of data frames. So here, as I said, this is the first way to create a data frame. We use the function data frame. Open brackets, here you have the names for the columns, and then you have on the right side the vectors that make up the columns. So if we look at this, we see the data frame as such. Alternatively, we could first define a list. You see, I copy-pasted the code from above because it's basically almost the same. If we look at this list, we see that it is now printed in a different way. Nevertheless, we also might not be surprised that if we look at the underlying type of df1 above here, we see, as I said in the beginning, type of always gives us the underlying basic base object type. If we ask for the class of df1, we see here that it is a data frame, and we could also look at the attributes of df1. Here we see the particularities of the data frame. It has the names part, here the class and the row names. This is particular for the data frame, but that's just for your information. Now, if you want to take list 1 here and you want to turn it into a data frame, you can do so by using the function asDataFrame, and then you can pass list 1 to this function. And if you want to test whether an object is a data frame, you can use this function isDataFrame. So data frame 1, we know that is actually true, it is a data frame, but here list1 is not yet a data frame, so the function returns false. But here, after using the function asDataFrame, the function isDataFrame now returns true. IsDataFrame is sometimes useful because of this behavior. You can't use typeof to understand whether an object is a data frame or not, because it will always return the underlying base object type list. So isDataFrame can be useful in the instances where you are actually enforced to test whether something is a data frame or not. But usually, because of the specific printing behavior of data frames, that's quite obvious anyway. Now, just some words on tibbles. Tibbles can be thought of as a modern version of the data frame. They are provided by the package tibble. Most of the time we will use tibbles in this course. But that doesn't mean you should skip learning about data frames. In the end, I would say a majority of the R code is still making use of data frames. So what I would recommend you is to really make sure that you understand the difference between data frames and tibbles. Because data frames continues to be widespread, and tibbles are often a good choice to be used. Here, this is the definition of the data frame we used before, and if you want to take this data frame, you could also use any other list. You want to turn it into a tibble, you can use the function asTibble from the tibble package. It is really straightforward. Just pass as a mandatory argument the name of the object you want to transform into a tibble. And then you immediately see what has happened. The tibbles are printed also in a slightly nicer fashion than data frames, but I suggest you try that out yourself. And when you do so, make sure to also answer the following question, because sometimes you take a tibble or a data frame and you want to extract single columns. To do so, you use the square brackets, but it actually makes a big difference whether you use a single or double square bracket. It mimics a little bit the behavior of the list, but I recommend you to try this out. So to better understand what's the difference between extracting columns by using a single or double square bracket. And then maybe if you're onto it, you could also try and think about how you can test for the type of the column of a tibble or data frame. Because remember, right, the data frame is basically a list, and the list is contains named vectors. And each of the vectors can be of a different type, because that's the decisive property of a list. So you might want to test for the types of the columns of a table explicitly. And I just leave it to you to try that out and then see how it works in a second. Okay, so here we have our data frame 1. As I said, if you want to make a tibble out of this data frame, we can use from the package tibble. We can use the function asTibble and then just pass the name of the data frame we want to transform. If we do so, we immediately see that the printing behavior is a little bit different. We see here explicitly that the dimension of the tibble is already given. And then the question was, what's the difference of the different approaches to extract columns from the tibble? So as in the case of the list, you can do that with the square brackets. If you use the single square bracket, the result of extracting the column will be, again, a tibble with a different dimension now. So we just have one column here. If you use the double square bracket here, then you actually extract the underlying vector. And this also means that if you want to test for the type of the underlying column, you need to follow the second strategy, because then you can use the type of function to understand whether what the underlying type is. So in this case, it's character. And if you did the same only with a single square bracket here, you would get the type of the underlying the tibble, which is the list, because typeof always gives you only the base type underlying the more advanced type, and here the base type underlying the tibble, as in the case of the data frame, is the list. So type of 5.1 tibble will always return the value list. Now, there are a couple of other functions that are useful in this context. So from the package dplyr, there's the function glimpse, which gives you some more information. It's nice if you want to get a first overview about a table. So here you see, okay, having a glimpse on TB1 shows you, okay, it has 5 rows, that's 2 columns. It gives you a preview of all the columns, and it immediately indicates which is the underlying type. So that's useful. Another thing that doesn't require any additional packages that I use a lot is the function head. Head by default gives you the first 5 rows of a data frame. That's very useful if you just want to get a first overview for a very long data frame. You can specify with the optional argument n that you want to see only, for example, the first two rows of the data frame. That is often useful practice. And then another quite specific function is the one called view. View is particular in the sense that the first letter needs to be uppercase. And if you call the function view, you shouldn't do that in a script regularly, because it opens a new window and it gives you here this kind of Excel-like preview where you then can also order the table here in the descending order, etc. You can also filter it, which is kind of useless for a small table like that. It becomes handy if you have a bigger table and you want to search for particular entries. You should also beware calling view on very, very big data tables can really slow down your computer. So if you have, I don't know, 1 million rows or so, and you call view on that data frame, you can actually have a bad surprise with your computer. But in general, view is quite useful, especially when interacting with a data frame. Now, as I said, data frames are among the most widely used data types in R. And this is probably why several strategies of how to handle them have emerged. There are 3 different approaches of how people address data frames, how you can transform them, engage in this thing called data wrangling. And each of these strategies, very broadly conceived, can be associated with, I would call, an R dialect. This can be a little bit confusing for beginners, so I mentioned this here explicitly, because it's important when you search for solutions or suggestions to handle certain challenges in the internet, because people are usually very much into one of these 3 dialects. Now, we here mainly rely on the so-called tidyverse dialect. In my view, some people disagree, it's the one that's easiest to learn, because in my view it has the most consistent syntax, so it's particularly easy to comprehend. And once you follow this tidyverse dialect, you usually always take data frames and to transform them into tibbles, because tibbles are designed such that all the tidyverse functions work properly on them. There are alternatives, however, and there are actually a couple of people who criticize the tidyverse dialect for being too imperialistic in some sense. So the tidyverse dialect is developed mainly by the people who also developed RStudio, and Hadley Wickham, who did a lot of amazing stuff for R. I think he's the guy who initially came up with this kind of dialect. And alternatives are, on the one hand, the base dialect, or the classical approach of handling data frames. And people who follow this base dialect, they don't transform data frames after all. They usually work with data frames directly. Another very prominent alternative is the data table dialect. Here, people take the data frames and transform them into data tables. And I would say the data table dialect is a little bit more difficult to understand than the tidyverse thing. It's a little more specific, but it's way more faster. That means that once the data you're handling surpasses a certain size, and we're talking a lot about several gigabytes here, then makes a lot of sense of switching to the data table dialect. So I'm quite pragmatic on that. I'm not a big adherent of one or the other. I must confess I'm not working with the base functions that much. In my research and applied work, I'm mainly using the tidyverse and data table, depending on what's more suitable for the case at hand. So I don't want to convince you to always go for the one or for the other, but I ask you to be vigilant about these differences, because if you go to Stack Overflow and ask people for suggestions to follow a certain problem, then you will be confronted with very different answers. And these different answers can be inspired by different dialects. And for somebody who has learned R in the tidyverse version, it might be confusing to get a response that refers to very different functions, because these functions come from the data table dialect. So I'm saying this that you are not confused and that you can choose the answers you get for your questions explicitly and with the knowledge that these different dialects exist. And once you feel very comfortable with R, it's fun to read a bit about their pros and cons and so on. And then maybe you are ending up convinced and you're always going for the data tables, or you become like myself and you do whatever suits best for your particular problem at hand. But especially in the beginning, I suggest you be vigilant, and I also suggest you stay consistent in the way that within one script you're always following the same dialect, because this avoids issues that when you, for example, use a function from the data table dialect applied to a tuple that can lead to some weird results.